let's move on to the next topic of electrochemistry, conductance of electrolytic solutions. So first we are discussing factors which affect electrolytic conductance. The first factor, which affects electrolytic conductance is the nature of the electrolyte. What electrolyte we take in the electrolytic cell? Electrolyte, as I have told you, is that substance which allows the electric current to pass through it. So if it is able to pass the electric current easily, more to the greater extent, we will call that as strong electrolyte. So these are some examples of strong electrolyte: sulfuric acid, hydrochloric acid, nitric acid, even strong bases we can take, NaOH, KOH, etc. If it cannot pass to that extent, it's a weaker electrolyte. Acetic acid, ammonium hydroxide, but they allow the electric current to pass through it. So these two are electrolytes. If it cannot allow the electric current to pass through it, it is non-electrolyte. That means we can take the covalent compounds in water like urea, you can have sugar, glucose. They will not allow the electric current to pass through it. This is the first factor, right? Second factor is size of ions. See, if the size of ion is big, its mobility will be less, so its conductance will be also less. So we can say larger the size of ion, lesser will be its electrolytic conductance. So same we can have even in solvation. You remember that if the ion is smaller in size, it will be more heavily hydrated, means we can say more solvated. If it is more solvated, means it will become larger in size. Larger size means its mobility will be less and conductivity will be less. Conductance will be less. So this is here in the second factor. I hope you followed it. Second factor says larger the size of ion or greater the solvation, lesser will be the electrolytic conductance because of lesser mobility. Third factor is nature of solvent. Now, there are certain solvents which are polar. If it is having more polarity, the ionization will be greater. It will be able to ionize the electrolyte to greater extent. Greater the ionization, greater will be the conductance. That means polar solvents will have more conductance. Same we can even relate with viscosity. More viscous means more interactive forces are there. More interactive forces means conductance will be less. This is the third factor. Now we move on to fourth factor. Fourth factor talks about concentration of the solution. Concentration of the solution, we say when we add water, means with dilution, the ionization becomes more. More the ionization, more is the conductance. So we can again say concentration of the solution decreases, means there is more dilution. More the dilution, more will be ionization. More the ionization, more will be conductance. That is the fourth factor, right? Fifth factor, temperature. With the temperature, ionization will increase. More the ionization, more is the conductance. So we can say here directly proportional. More the temperature, more the electrolytic conductance. This was all about electrolytic conductance. Electrolytic conductance means conductance of the electrolyte which we have taken in electrolytic cell. I think in physics people talk about metallic conductance, metallic conductor. So we'll see what is the main difference between the metallic conductor and electrolytic conductor. In metallic conductor, the flow of electricity is without decomposition, means that metal through which the current is passing, nothing happens to it. Decomposition doesn't occur. Whereas in electrolytic conductor, when the current passes, ionization occurs, so decomposition occurs. Those ions form, they move to the respective electrodes. If one may get deposited, oxidation may occur, reduction may occur. That is the first difference between the two. The second difference is in the metallic conductor, the flow of electricity is because of the flow of electrons. Whereas in electrolytic conductor, it is because of the movement of ions. Ions carry the electricity. Next factor, the difference between the two is that I think for electrolytic we have already discussed. Conductance decreases with increase in the temperature. The metal wire gets heated up. The conductance will be less. Whereas here it increases because with the temperature the ionization increases. The fourth comparison between the two. In metallic conductor, resistance is offered by the vibrating kernels. It means when the electrons are flowing, the positively charged metal ions are there. Their vibration is causing the resistance. The metal ions are called as kernels. So the vibrating kernels offer resistance to the flow of electrons. Whereas in electrolytic conductor, the resistance is offered by the interactions which are there between the ions. The interactions and viscosity that we have discussed here. More the viscosity, lesser will be the electrolytic conductance.